Hey folks, this is Shane from Performance EV. Today we're going to try and get the motor running in our electric Porsche. Welcome to the channel. Thank you so much for joining us. For those of you new to this channel, this is my project to put a Nissan Leaf motor into a Porsche 911. So it's been going on for, well, quite a while now. But over the last few weeks, I've been focused on getting the important things wired up. So that's our getting the inverter, getting the high voltage wires from the inverter to the motor, getting the signal wires coming out of the inverter wired up, and getting things like the precharge kind of circuit in place, getting the relays in place, and getting the some test batteries fitted so that I can hook them up to the inverter and send power to the motor. So today we're going to do the last little bit of tidying up on the kind of high voltage wiring. So that's the relays for switching on the precharge circuit and the main contactor when the power or when the signal comes from the inverter, so that then there's power going to the DC bus and we can actually drive the motor. So we've got a little bit more testing to do on that, and then assuming everything looks okay, at that point I've kind of run out of excuses and I've got no real choice but to switch everything on and try and press the accelerator pedal. So come on, let's see what happens. I'm going to do a bit of a time lapse of me doing some of the testing, but to be honest, it's just a whole lot of this. So I won't bore you with the details of that. I found some issues with the wiring again, and then I also got some input from a few people. After I did a bunch of the testing, I noticed that I was having trouble getting anything to happen with a couple of relays, and I realized that I'd misinterpreted their capabilities, to be honest. They were still a little bit too bulky for the signals coming from the inverter, so I've switched over to using something a little bit lighter. So the eagle-eyed amongst you will probably recognize the block of relays I used on my original precharge circuit when I was building it totally standalone. So this little unit is designed to work with things like the Arduino little processors, but the signal that's coming out of the inverter is basically exactly the same signal, the type of signal that would be sent from those Arduino boards. So I can just wire this into the inverter and then provide the board with positive and negative, or positive and ground, and that should then allow it to trigger the main contactors and main relays to send through the power. So we'll get the wires put in place, and then we'll test this out. Okay, we've got our updated wiring in place here. So we've got
I guess, 3 types of power coming in from what will be the car. So it'll be ultimately from starting off in the 12 volt power of the car. So we've got 12 volt, we've got ground, and we've got 5 volt. The 5 volt is actually provided from the inverter, and it's used in 2 places. One is for the potentiometer on the accelerator pedal, and the other is for powering these inverter boards. Not inverter board, sorry. This board with the relays on it. So we've got 5 volt and ground going to this relay board, along with 2 signal wires which come from the inverter and have the signals for the precharge and the contactor. Also coming into a separate relay is 12 volts and ground, which are both going to this separate relay which is underneath here. That's same as one of the original ones that I had wired up, and that's got the output going to the negative contactor. Each of those high power relays also has a ground going in, with the 12 volts basically provided at the right point by one of these 3 relays here. So when I switch on the power, that will send 12 volts to the negative contactor or high voltage relay. I'm calling them contactors, but these are really, they're not quite powerful enough to be contactors. They are just high voltage relays. So 12 volts will be applied to that. That will close that and complete the negative side of the circuit, the DC circuit, that is. Then when the inverter switches into start mode, it will send a signal to the board here, which has 5 volts and ground coming into it. That will then click open the pre-charge relay, which will send 12 volts to the pre-charge relay, which will then open up and allow the high voltage to go through the pre-charge resistor. Once the capacitor inside the inverter reaches around the same voltage as the battery pack, which is a parameter I can set in the software, then the inverter will switch from pre-charge relay to the main contactor. So it'll stop sending a signal on the pre-charge wire, which will then open up this relay, which will open up the pre-charge relay and stop sending power through here. And at the same time, or probably slightly before, it will send a signal through the main contactor signal wire, which will close this pre-relay, which sends 12 volts to the high voltage relay, which will then complete the positive side of the circuit, and we'll have our, I guess, maintained high voltage going through. So now I need to test that all that works. So first off, we're just going to make sure that on turning on the power to this entire circuit, that the negative relay fires. Then we'll switch on the inverter, so move it to start, probably using the software rather than the hardware switch that I've got, and that will flick on the pre-charge relay. So we'll double check that everything's going okay with that. And then we'll need to move to the next round of testing, where we'll have to hook up a battery to the various relays and set a parameter in the inverter for what the voltage of that battery is, so that it'll switch from pre-charge to the main contactor. And we'll see how that works. So for that one, we'll probably just go with like a 12 volt battery so we don't blow anything up. But let's get to it. So we'll do one last check now to make sure that all of the relays are closed, and then we'll start with our testing. Okay, so I definitely heard something fire there. That should be the negative relay. And we now have continuity there, so that is closed. So now we should have the inverter powered up, so it should be sending a Wi-Fi signal that I can connect to. And we can now select to start the inverter. So I can hear the inverter started, and I can also see that there's now power going to the board here. So I need to see has the precharge relay switched on. Okay, so the precharge relay hasn't switched on, so let's check out why. Okay, that's on. That was just a connectivity issue. Okay, so now we're going to shut this all down, get 12 volts wired up to the positive and negative, and go from there. Okay, so here we've got our 12 volt lead acid battery wired up. It's only a small 7 amp hour one, so not a huge amount of power, but that's connected through to the various relays, and so is ready to provide some sort of power. Okay, so we sent some power through the inverter to switch it on, and that does seem to have fired some of the relays, but not all of them. And I'm also seeing some strange behavior to the signal from the throttle. So I want to check down with the contacts first to see if they're actually switching on when they're supposed to, and then we're going to go and dig around in the front of the car and just see if I did anything wrong or pulled anything out on the throttle setup, and then hopefully we can start to get things moving. Okay, so we've fixed the problem with the throttle. I had managed to disconnect or knock out the ground for that particular one, so it wasn't sending a variable signal. And then we've also updated the parameter in the software to better reflect what this battery is pumping out. So now I can see the DC bus is, it's there. Not a huge amount of power going through that, so there's no real heat. But yeah, I think we're in a pretty good place. So what I'm going to try and do is switch the inverter on through the hardware. So that involves turning on the power to the switch for forward and reverse, which will send a signal to the inverter that it needs to do something. Sorry, so the first thing I had to do was actually to send basically a switch live, just a brief burst of 12 volts to the on-off switch effectively within the inverter, which has switched it on, and rather excitingly has switched off the pre-charge signal and switched on the DC signal. So now I just want to check check the main contactor and see that it has actually switched on. So we've got continuity across there. So when the power first goes through the inverter, sent a signal to run through the precharge, switch that on, and that has now allowed us to go through to the main contactor. So I'm just going to check the parameters on the software. Yeah, we're in run mode, got voltage, got signal. So let's turn on power now to the forward and reverse and see what happens. So we've now got the car in forward, We've got voltage on the DC bus. I'm sure I'm missing tons of stuff, but I'm just going to try and prod the throttle pedal and see what happens. Alright, so here goes nothing. We've got our inverter switched on. It's got power going to it. The DC bus is fully live. Precharge relay is off, main contactors on. And I can see signals for the voltage and the potentiometer in the e-throttle. So I think the only thing we can do is floor it. Alright, increasing, increase, and it tripped out. Alright, so something did happen. We actually got power coming from the inverter to the motor, and then it tripped an overcurrent protection. But that's something. Alright, I'm gonna go check a bunch of parameters, and we'll try again in a minute. Alright, back for another try. Everything's switched on again. As I mentioned, I've changed some settings. So here we go. It's alright. I can see the throttle signal increasing. Oh, current's changing. I hear an engine. It's moving. Yes, it's moving. Awesome. That is awesome. Alright, I need to go check the footage from the other camera and see how that looked. Alright, that actually looked really cool. I think what I'm going to do now is, for the ubiquitous wheel spinning under electric power shot, I am going to have to put the wheels back on, set the camera up again, and go for another run. And yeah, let's go for it. Ah, that's awesome. Alright, that was awesome. We got the wheels turning. 12 volts of high powered battery. So I think what I want to do now is give it a go on slightly higher voltage. So I've got a row of 6 batteries here, which gives us about 72. So let's see how it does with that. I'm not going to go too much further because I was hearing some grating in that from the brakes, and I think things are binding a little bit, but the motor's running and that's what counts. I was really nervous that something would just start smoking or blow up or go really weird when I pushed the throttle pedal and actually sent power to the motor. But the motor itself actually sounded really smooth. You could hear it, spinning up, and even with the only putting 12 volts through, you could still feel that there was power there. So that's really cool. Now, this kind of did let me see a few other things. So I could definitely hear some clunking from the differential, which granted I didn't have a huge amount of transmission fluid in, so I need to fill that up. But it looks like the brakes on the right hand side of the car are binding a bit. So that wheel was barely moving while the other one was spinning freely. So I think what I need to do is probably go in, just take the brakes apart again, make sure everything's moving smoothly, properly lubricated, that the parking brake's not kind of doing anything weird, put it back together, and hopefully have everything spinning much more freely. So yeah, huge milestone hit. Now I need to do some kind of basic mechanical stuff, and then if I can make sure the brakes are functioning properly so they're nice and free when pedal's not pressed, when the pedal's pressed, they're actually stopping the car, then I might try and see if I can just get it to roll back and forth a few times on the ground. But yeah, this is really cool. I'm really stoked that I managed to get the car running like this. Still, again, plenty of work to be done, but yeah, awesome to have hit the milestone. So I don't think there's much more to say on this particular one. Thanks for watching and sticking with us through all of this. Please consider subscribing and liking and leaving comments and all that sort of stuff. But till then, thanks for joining us, and we'll see you next time.